Fine. Hello. Let us discuss convergent evolution. Convergent evolution. We have earlier discussed divergent evolution, which is also called adaptive radiation. Convergent evolution is a type of evolution where organisms with structures from different embryonic origin being modified to perform the same function. So evolution where structures of organisms, though originating different embryonic origin, are made in such a way that they perform the same function. So yes, you see how I do it. Converge. Remember the other one was diverge. So this is convergent evolution. So organisms which show convergent evolution possess structures known as analogous structures. Analogous structures. Let us define what analogous structures mean. Analogous structures are structures with different embryonic origin but are modified to perform the same function. Okay, organisms with different embryonic origin but are modified to perform the same function are known as analogous structures. You can contrast with homologous organisms with the same embryonic origin but they are modified to perform different, that is homologous. Home one, then they diverge. But analogous structures with different embryonic origin but they are made to perform the same function. Okay, so analogous structures contribute to a type of evolution known as what? Convergent evolution. Okay, but homologous structures contribute to a type of evolution known as divergent evolution or adaptive radiation. Hope you get the difference. Should differentiate. One more time for you to get it clearly. Analogous structures contribute to a type of evolution known as, yes, type of evolution known as convergent. So analogous structures contribute to a type of evolution known as convergent evolution. Because what are analogous structures? These are structures with different embryonic origin made to perform the same function. Convergent evolution. Homologous structures are structures with same embryonic origin but they are modified to perform different function. No wonder it is called, they contribute to divergent evolution or adaptive radiation. You have to adapt different. Examples of analogous structures. Examples of analogous structures includes one, wings of birds and wings of insects. If I have a bird, just imagine a bird, the flying one, bird, a bird with an insect, and compare their wings. Are they the same? No, they are not. Wing of a bird originates from pentadactyl limb I discussed and homologous structures. Yes, with muscles, blood and bones. But for an insect, it is different. It's just an exoskeleton arising from its exoskeleton. So they are not the same. But what is their role? What is the role of the wings of a bird? Flight. You're right. What is the role of the wings of an insect? The same, flight. So different embryonic origin, but they are modified to perform the same function. Wing of a bird is for flight. Wing of an insect is for flight. Are they originating from the same origin? No, but the function the same, contributing to convergent evolution. Another example is eyes of vertebrates. Vertebrates like us, human beings. Eyes, our eyes, okay? And the eyes of mollusks. You've seen a snail. It also has, they also have eyes, okay? But theirs, you look at how they are, cannot be the same as ours. They are not the same. But what do you think is the role of the eyes the mollusks have, like the snake? For sight, for seeing. Our eyes are for seeing. So they may not look the same. They are not the same because they don't come from the same origin, but the role is the same, sight. Limbs, the projection, either the hind limbs like the legs and the forelimbs, the limbs of vertebrates or mammals, and the limbs of insects. They are not the same. Mguu wako na wa housefly cannot be the same. But what is the role? What is the role of our legs, our limbs? For walking, running. What is the role of the limbs on that one? Of arthropods, housefly, cockroaches. What is the role? The same role. For walking, for running, the same. Different origin, same function. Okay, another one is the presence of thorns. Thorns, amoeba. Thorns in stems and leaves of plants. And spines in animals. We have organisms or animals with sharp uh, projecting structures. There is one, forgetting the name. This animal that if you approach it, you will see the spines or those thorn-like structures. It projects even further for protection. What is the role of the thorns in stems of some plants and even their leaves? Protection. Protection. So whether they are thorns in plants, protection. Spines in animals, protection. Okay. You'll remind me the name of that animal. You can type in the comment section the name of that animal with spines. So the spines in animals, the thorns in plants, they play the same role, that is protection. Yet thorns and spines are different. They originate differently. So that those are examples of analogous structures. Structures from different embryonic origin but modified to perform the same function. Those are analogous structures. So what is the importance of these structures? What is the essence of having structures, though originating differently, performing the same function? It is because some organisms are forced to exploit or inhabit the same environment. So if you are living in the same environment, you are likely to share the same food. You are likely to face the same problems. You're likely to experience, so you share experiences. So because of that, though you may not be the same, morphologically, physically, you're not the same, but for the sake of survival, you have to adapt. You have to perform the same. You have to somehow live the same way. That is how exactly analogous structures help organisms to exploit the same environment with those species, different species, but exploiting the same environment. So examples of analogous structures. Thank you.